Welcome to ePathshala lecture series on computer science. In today's module, we will be discussing about two different topics. One is big data approach to analytics, another one is how the World Wide Web is actually the big data. So, what are the learning objectives of this particular module? This module actually offers you certain examples with which we can understand how big data is different from traditional data environment, followed by we will understand big data approach to analytics. Then we will be in a position to appreciate the potential of big data in various domains and how analytics may be applied in those domains, followed by the importance of data offered by the World Wide Web, and finally, we will be in a position to understand what research can be applied on web data for the purpose of making it useful to the society as well as to various organizations. So, first let us start with how big data is different. Fundamentally speaking, big data is generally automatically generated by various machines. For examples, in the real world, there are many automatic data collection tools that have come into picture. Best example is Crawler. Crawler is actually a program that is run by search engines for the purpose of indexing all available web pages over the World Wide Web. Now, this Crawler program can be considered as an automatic data collecting tool. So, big data is fundamentally collected by means of automatic data collection tools. The second important point by which big data is different is big data is completely or entirely a new data source. The reason for this is when we consider big data is associated with 4 different characteristic features which we discussed in the previous module, like the velocity, the volume, the veracity and the heterogeneous structure associated with that particular data. So, therefore, big data can be treated as a completely new data source. The third point by which we can view big data in a different perspective is it is not designed to be user friendly. The reason why it is not user friendly is as and when you collect a data which we treat to be a big data, that will not be easily applicable for any analysis, or a normal user or even an expert user cannot easily understand what exactly is available in the data. Fundamentally, it will be a raw information or raw data. The fourth point with which you can differentiate big data with respect to the rest of the environment is it can be messy and ugly. This point is related with the fourth important characteristic feature of big data, which is veracity. Veracity, as I already mentioned in the previous module, it is nothing but uncertainty in the data that has been collected. So, uncertainty may result in various missing informations, it can result in various inconsistencies, or it can mean redundancy in the data. So, the data that we collect for the purpose of doing analysis, and when we consider it to be a big data, it will be associated with all these uncertainties. That is the reason why it is said to be messy, or sometimes it is even ugly. In other words, it is dirty in nature. And one important point with which we can clearly distinguish big data with respect to the rest of the domain is, till date no standards have been evolved for the purpose of analyzing big data or for the purpose of equating the quality of big data with respect to the rest of the data sources available across the globe. So, no standardization has been evolved with respect to big data. So, these are the various features with which we can clearly distinguish big data with respect to the rest of the data environment. Big data, when applied in any environment, or when we are trying to apply analytics with respect to big data, how big data can create an impact. This is what we are going to discuss now. Traditional data analytic environment is fundamentally structured in nature. Structured here in the sense the data is taken, it is been cleaned and it is kept ready for the purpose of analysis. Now, when you want to run any analysis on a given data set, the data set fundamentally should be in a format which is compatible with the algorithm, the analysis algorithm. Therefore, the data need to be structured. So, traditional analytics is associated with structured environment. And moreover, in traditional analytics environment, the analysis is run repeatedly at frequent intervals of time. This is how actually traditional analysis happens. But when we consider with respect to big data analytics, in big data analytics, data keeps coming into the environment. Therefore, it is going to be iterative in nature. So, whenever we are trying to run any analysis, the analysis need to be applied on an iterative fashion, and the analysis is not going to be run repeatedly. It is going to be exploratory in nature. So, these are two fundamental points by which you can clearly distinguish big data with respect to data analytics applying big data. In traditional analysis environment, what generally we do is the business users actually determine the queries. So, for a given environment, take for example, a data warehousing environment, business users or experts normally identify what type of analysis will be run in the given environment. So, they will have to predict the queries that might hit the warehouse, they will have to identify the nature of the queries, and accordingly they will define the queries. What the users has to do is, the users have to identify what queries exactly they are going to run, and accordingly they will provide that query to the data warehousing environment, and the IT experts or people who build that system, what they will try to do is, they will try to identify a suitable schema in which the data can be made available for the purpose of querying. So, in a traditional analytics environment, business users determine the questions, an IT team builds a system to answer the known questions. But in a big data analytics environment, it is the reverse way. The IT team and data experts actually deal with the data, they do lot of pre-processing on the data, they identify what exactly is relevant, and then they will try to provide a quality data, quality here in the sense the data which may be used effectively for querying or for the purpose of analysis. So, when you want to make the analysis quality in nature, then the data should not have any form of ugliness or dirtiness. The ugliness and dirtiness, as I have already mentioned, may be redundancy or it can be inconsistent information, sometimes it may be noises or it can even be missing information. So, IT experts and data experts need to work together for the purpose of eliminating all these inconsistencies, redundancies, missing values, etc., for the purpose of making the data ready for any type of analysis. And what the business users will do is, the business user provided with the given data, they will explore and they will identify patterns. So, the process which is happening in big data analytics environment is completely opposite to that of the process that happens in traditional analytic environment. Apart from these two properties, with respect to a traditional data analysis environment, there is a constraint for hardware. Therefore, what happens is, we cannot deal with the entire data set. Instead, what we do is, we try to collect samples, then we run the analysis over the samples, which is not the same as in big data analytics. In big data analytics, we need to deal with the entire population of data set. Now, in a traditional analytic environment, whenever we are dealing with respect to sample data, what is that we need to do is, we need to propose a hypothesis, that is, we should start with a hypothesis, then we need to test the hypothesis against the selected data. Only then we can come to know whether the data is feasible for the purpose of analysis or whether the expected pattern is available or exhibited by the data that we have selected. But one drawback here is, the sampling that we perform, according to the type of sampling, the nature of the data as well as the pattern exhibited by the data might vary. So, when we are applying different sampling techniques or when we sample different data from the same set of population, then we may end up with different types of results as a part of the analysis that we are going to perform. But in the big data environment, this is not the same. In big data environment, we take the entire data, then we explore the entire data for the purpose of identifying some type of correlations. So, what exactly we are trying to do is, we take the entire population data and we try to run certain analysis to identify what sort of correlation is exhibited by various attributes that is available as part of the data. Then we will be in a position to provide an actionable insight into the data. So, data actually leads the way in big data analytics when compared with that of traditional data analytics. Once we have prepared the data for the purpose of analysis, next what is that we are going to do is, we are going to run the analysis over the data that is set ready. This happens in traditional data analytics, but in a big data analytics, we will have to take the data as and when it comes, and then we will have to do or run the analysis in motion. In other words, data will be moving and we will have to run our analysis over a specific time window, and in that time window we will have to capture various parts of the data at a specific point of time and run our analysis during that particular point of time. So, these are all certain parameters or certain features by which we can clearly distinguish what is happening in a traditional analytic environment and a big data analytic environment. So, this example and the parameters that we discussed will help you in understanding big data approach towards analytics. So, what is that we can say here is big data has provided a greater impact in terms of the analysis that we are performing. So, we are not doing analysis with the same perspective as we do in traditional analytic environment. Instead, a different dimension or a different perspective is what is applied in big data analytics. This slide actually provides you an idea of where exactly we are in terms of big data. So, here this slide has a graph. In this graph, you can find three axes. One axis is about the volume, the second axis is about the time, the third axis provides percentage of uncertainty in the data and variety here in the sense heterogeneity in terms of the data. So, now you can find we are exactly here in this location with respect to the year 2015. So, what does this particular graph provides you is, from this graph we can infer the amount of data which is going to be available for the purpose of analytics or analysis is increasing. So, we can find variety of data coming into picture. So, we have enterprise data, voice over IP data, social media data contributing to a major extent, and data from sensors and other devices. And as the variety of data increases, naturally the percentage of uncertainty in the data also increases. The reason is, when data is collected by any automatic agent or by automatic tools, naturally there is a chance for the tool to malfunction or to miss any data. That is the reason why veracity increases along this axis. And in this graph you can find a dark shaded black graph or a line which clearly tells what is the percentage of uncertainty in the data, and this graph is exponential in nature. What does it means is, the percentage of uncertainty in the data keeps increasing as we encounter more and more heterogeneity in terms of data as well as in terms of volume of the data. So, what exactly we can do with these data? Fundamentally, we can take these data, apply some form of algorithm, and then we can aggregate the information. Also, we can apply statistics. For example, in data warehouse and in online analytical processing environment, what is that we can do is, we can collect these data over a period of time, apply some cumulative function with which we can aggregate or we can summarize the data. And also we can identify certain statistical parameters with which the quality of the data as well as the patterns that is available in the data may be explored. Secondly, we can index, we can search, and then we can query the data. So, we can apply keyword based searching, or we can identify certain patterns like say XML pattern or an RDF pattern from an XML data or an RDF data. Thirdly, we can perform knowledge discovery. So, we can run data mining algorithms over the data, explore patterns or identify patterns, and then use it for the purpose of decision making. And we can also do statistical modeling. For example, you can take user data collected from say a World Wide Web environment, apply a model and model the users who are performing say web search or who are associated with certain applications like social network applications. So, modeling of user, modeling of data and modeling of various other parameters can be done with these data. Now, let us go through few use cases or domains where there is a real challenge for doing analytics and where there is volume of information available. The first domain is healthcare domain. So, what is the today's challenge in healthcare domain is, it is expensive office visits. So, we cannot expect patients or doctors to come to a specific location and perform say test or diagnose with respect to various patients. So, all that we can do is, we can go in for remote patient monitoring. Now, when we are doing this remote patient monitoring, we will be dealing with lot of sensor data which need to be taken into account. So, we will have sensors attached to the patient's body. These sensors will transmit various health information which can be accumulated in a server, and some kind of preventive care analysis can be made, reduced hospitalization can be taken into account. So, these are all possible things which can be done when we are going in for collection of such voluminous data and when we apply analytics over that environment or domain. The second important domain where you can apply big data analytics is manufacturing. So, in manufacturing there is lot of need for in-person support with respect to, say, for example, a production unit. So, what we can do is we can depend on product sensors. So, now when we deploy product sensors in a manufacturing unit or in a production plant, then these product sensors will transmit various data with respect to the quality, with respect to the dimension of the product that has been developed, or with respect to the characteristic features of that particular product which has been manufactured. So, with that we can go in for automated diagnosis and support. So, we can clearly say whether a product is of quality product or it is a defective product. The third important place where you can use big data is location based services. For example, we can always have a zip code for various locations in a city. So, we can collect such real time data and we can go in for geo advertising, and also we can look in for local search within a specific domain. So, these are all certain big data use cases wherein there is a real challenge for collection of big data, and when analytics is applied in this domain, naturally there will be very good outcome which may be used for the purpose of betterment of the society. Now, with respect to big data, where exactly you can find big data? One best example or one real world place where you can find big data is the World Wide Web. So, World Wide Web is going to be considered as the actual big data. Now, let us see how World Wide Web acts as the actual or original big data. Take for example, in the recent days we have found many organizations that perform sales over internet or that apply e-commerce transactions are trying to perform a 360-degree analysis over their customers. Now, what exactly is this 360-degree view of the customer? Originally, organizations or business experts, what they were trying to do was they were trying to take details about customers in a relational format, like for example, name and address as part of this table, then they will apply the analysis. But with respect to the name and address of a customer, it is very difficult in the recent days for people to come up with certain analysis and to apply that analysis in decision making process. The reason is, in the recent days people are performing transactions over the internet. Therefore, name and address is not going to be a matter which may be considered for the purpose of decision making process. So, in the recent days what organizations are trying to do is they are trying to apply analysis about a customer in all angles. That is what you mean by 360-degree view. So, for example, a customer may be associated with a social network environment. So, they might have posted some comments or say review about a product in social media. So, they can take this information for the purpose of analysis. Then they may have a video uploaded. The customer might have uploaded a video about the usage of a particular product or about comments related with a particular product. Such videos can also help the business people to understand how exactly customers are making use of their product. Then customers may be associated with emails. So, customers might have exchanged views about their product, about the products that they have purchased, and such emails to organizations. Normally, when there is a defect, customer might say about this defect and email it to the customer support. So, such emails might prove to be very valid for the purpose of analyzing what exactly a customer is thinking about that product. So, all these data when taken and considered for analysis, then it will be considered as a 360-degree analysis about the customer. Now, this is what is happening in current scenario. When actually we are trying to capture customer information from the World Wide Web, what actually happens is only 2% of the browsing sessions actually are completed with respect to a purchase. What does it mean is, when a particular customer is browsing for various products and when they want to purchase a particular product, it might happen only 2% times. So, what about the rest of the data? The rest of the data may be related with various other customer actions or activity in a particular website. For example, the customer can view the various features of a particular product. The customer can even add that particular product to the cart. Likewise, there are many other activities which a customer might perform. What exactly is captured in the transactional environment is only a purchase which is complete in its nature. Complete in its nature here in the sense, only when a purchase is performed by the customer, then it is said to be complete. Only such completed information are actually tracked in transactional environment. Now, what about the rest of the data? The rest of the data goes unnoticed. Now, what I am trying to say here is, with the 2% of the data, it is highly impossible for us to do an in-depth analysis on the customer and arrive at a conclusion. So, what is that we need to do is, we need to collect other informations like what activities the user has performed in a website, what data the user has provided from kiosk, or what data the user has accessed from a kiosk. There are lot of mobile applications to which users are interacting with. So, what data do the customers provide to these applications? Then there is social media, what information the customer has posted in social media or exchanged in a social media. All this information can be taken from these environments. Apart from the data, there are also behaviors exhibited by customers in online environment. What may be these behaviors? Like the purchases performed by the customers, product views performed by customers, requesting for help, forwarding a link to a friend, posting a comment, registering for a webinar, executing a search, etc., can be treated as various actions or activities which are executed by customers in a website wherein they are looking in for purchase of a product or for a product. So, what exactly these data reveal? So, that is what web data is actually trying to reveal. So, first important fact which web data reveals is shopping behavior. How a customer comes to a site and begins shopping. So, when you are analyzing or when you are tracking activities, what exactly you can analyze is, you can analyze what search engine do the customer use. Because when I am to purchase a particular product, what fundamentally I will do is, I will first go to a search engine, place the name of that particular product as a query, and then look in for description related with that query, or in other words, I look in for description related with respect to that product. Now, results will be provided by search engine. So, I can make use of the results, and in that result there may be one web page relating to say an e-commerce web page where exactly the product is being sold out. So, I can easily identify as a customer entered my website through a search engine or by normal browsing. Then I can look in for what specific search terms are entered by a customer. So, if I want to purchase a mobile phone, then what type of search query am I entering into that e-commerce website? So, that particular website I might type say simply mobile, or I can provide the brand name of the mobile, or I can provide a feature related to the mobile. According to the search queries provided by the user, different types of analysis can be performed and different conclusions can be arrived about a customer. Certain customers even bookmark about a particular product, or they might add the product in their wish list. So, all these activities when analyzed will provide useful information about the customer. Apart from that, we can also look in for what products the customer has viewed in a particular portal, who actually drilled down further, drilling down here in the sense looking in for more specific information. For example, I can provide a search query called say a mobile phone, then that particular e-commerce web portal might have provided me some thousands of mobile phones as a search result. Then what is that I can do is, I can filter the mobile phones by using a brand name. Then I can further analyze or filter down the search results by means of say a specific feature which I am looking in for in a specific mobile. Likewise, I can drill down to various factors to the more even to the more atomic level information. So, which customer has performed such kind of drilling down actions can be easily identified, with which we can easily classify who are all customers who are very much worried about a specific feature in a product, or who are all generic customers who do not worry about features, but looking for simply the brands or simply the product itself. What can be done, or what can be the outcome of understanding such behaviors? Understanding how customers utilize the information available in a web portal can help to interact with individual customers, or even we can look in for different information that is offered in our site, whether it is useful or not. So, with such a research on the various activities performed by the user as well as the data provided by the user, we can easily identify whether the data that we are providing in our website or in our web portal is really useful to the user or not. Accordingly, we can make a decision. Sometimes we can even get into a fact that whether a customer is going to be a generic customer or whether a customer is a specific customer. So, what actually we are trying to do is we are trying to identify target customers. Fundamentally, we are segmenting the customers. So, once we identify a specific customer, then what is that we can do is we can apply different sales strategy on these customers, and we can apply another strategy for customers who are in general. What feedbacks are offered by the customer? What type of research is performed over these feedbacks? Some of the best information which is offered in many e-commerce websites are feedbacks provided by the user or ratings provided by the user. So, when the ratings are provided in the form of a text, what is that we can infer is we can infer the tone, the intent and the topic on which the user is trying to provide information. Now, what exactly we can do? Once user provides a rating or once user provides reviews about a particular product, then we can simply apply text mining over such data, and then we can infer what exactly the user is trying to provide or what product the user is really interested in or what exactly the user is trying to do in that particular website. So, to summarize, in this module we discussed about big data and we found big data is associated with lot of uncertainties, and this percentage of uncertainty keeps increasing when we deal with heterogeneous data or data in different formats. And we also found that there is no standard till date for the purpose of evaluating any data or research related with big data. Secondly, big data approach to analytics actually provides a completely new dimension to analytics. The reason is, in traditional analytics we are dealing with sample data, then we propose a hypothesis, and once the hypothesis is proven, then we say it is applicable to the whole set. But in big data analytics, we are not dealing with sample, we are dealing with the actual population set. So, when we are dealing with actual population set, we will have to identify what sort of correlation is exhibited in the actual data, and based on the correlation we can extract features for the purpose of doing analysis. Then there are many potential applications of big data like healthcare, e-commerce, real estate, etc., wherein we can easily identify or look in for big data, and there is a possibility for application of analytics. So, once when analytics is applied over big data, you can always find lot of use to the society as well as to common man. Web actually proves to be original big data. How it has proven to be the original big data is in terms of the volume of data that is offered, in terms of the variety of data that is offered, as well as in terms of the uncertainty that is prevalent over the web data. Fundamentally, when you take World Wide Web, there is lot of dynamism exhibited in World Wide Web. Dynamism with respect to the user, dynamism with respect to the data, as well as dynamism with respect to the services offered in World Wide Web environment. So, because of this dynamism, there is lot of veracity related with the data that we collect from World Wide Web environment. In other words, there is lot of uncertainty in the data. Also, we can find the volume of data related to World Wide Web data is very large, since we are dealing with millions of users, millions of web pages at the same point of time. Also, the rate at which the data is being uploaded and downloaded in a World Wide Web environment is different, and the rate at which it is uploaded is going to be completely different when we compare one day with respect to the other day. Because of these factors, we can always say web data is the actual or original big data. Thank you.